Welcome back to differential calculus class. So we are still on partial derivatives. But in this video, we'll be talking about cross partial derivatives. Cross partial derivatives. So assuming we are given a function, let's say we have function z equal f of x and y, and we are asked to find cross partial derivatives. So we can find the cross partial derivative of z with respect to x on y, and also the cross partial derivative of z with respect to y on x. So what do I mean by that? So you remember that in our previous video when we dealt with second order partial derivative. So in second order partial derivative, you have something like you have z xx and also z yy. But in cross partial derivative, what you are going to have is this: you have x, you have z x y, or you have z y x. So in other words, in the first stage, you differentiate, you find the partial derivative of z with respect to x, and in the second stage you redifferentiate the same, you differentiate that first order partial derivatives, and you redifferentiate with respect to x. But in the second order partial derivative, what we do is that instead of differentiating in the second stage with respect to the same variable you differentiated with in the first stage, you now differentiate with respect to the other variable. Okay, so let's take a look at some examples. Okay, then before the example, let's take a look at the notation. So we just talked about the notation. The notation could be for the second, for the cross partial, there is will be x, y. So in other words, or we have yx. Okay, so this is equivalent to d square z dx dy, and this is also equivalent to saying d square z dy dx. Okay, these are different notations we use. So at times we use notation like this. Let's say we have, so okay, let me just, this is also equivalent to fxy, and this is equivalent to fyx. So all these, what we have here are equivalent, and what we have here are equivalent. Okay. Now let's take a look at an example and solve that so that it will be clear. So an example so that you understand what I'm trying to say. So let's say we are told to find the cross partial derivative of this function. So let's say we have z equals to, we have 3x squared y raised to power 3. So solution, how do we solve this problem? How do we solve it? It's very simple. So we have, let's write the function 3x squared y x raised to power 3. What we are going to do is that we are going to first find the first order partial derivatives. So how do you find out? Remember, the first order partial derivative of z with respect to x will be represented by z suffix x, which is equals to. So this is a multiplicative function. So we apply multiplicative function over here. So what do I mean? What do I mean by that? We only focus on the relevant variable x, while we hold other elements of this term constant. So in other words, we are going to differentiate only x squared here. Okay. In other words, when you differentiate this x squared here, what are you going to have? We can show it as well. Let me just say 3 multiplied by, we differentiate this x squared with respect to x. then we hold this constant. So we are only concerned with this relevant variable. So in other words, we have 3 multiplied by, when you differentiate x squared, you have 2x. Then lastly, you have y raised to power 3. So here, the total, your final answer here will be 3 times 2x times y raised to power 2. Then you have 6x y raised to power 3. This is the first order partial derivative of z with respect to x. Now, if I want to find cos partial derivative of this, so it's going to be x z sub x y. So what I'm going to do now is that instead of differentiating this first order partial derivative with respect to x again, now I'm going to differentiate with respect to y. So my focus will now be on y in this stage. So I want to differentiate this. Let me write that here. So this is 6x y raised to power 3. So I'm differentiating this with respect to y, not x, because I'm looking for cross partial derivatives. So in other words, my focus will be on y. So, and you remember the said you allow other elements of this component to remain constant. So you hold them constant, you have 6x, then multiply by, you differentiate this y raised to power 3 with respect to y. Okay, with respect to y. Sorry. So now, if you do that, what you are going to have now is that you are going to have 6x multiplied by, you differentiate this y raised to power, it gives 3, you multiply the power by the coefficient of y, which is 1, 3 times 1, that is 3, then you have y, you subtract 1 from the power, you have 2. Okay, then you multiply the 6x multiplied by 3y squared, then you have 18xy raised to power 2. This is the cross partial derivative of x. This is the first partial derivative of z with respect to x on y. So let's also do the same for y. So let's find the first order partial derivative of z with respect to y. If you do that, this time around, you go back to the original function, the focus will be on y. So y you hold other elements in that term constant. So you have 3x squared, you hold them constant, then you differentiate this. So we have 3, you have y raised to power 3, then dy. Then this will be equals to 3x squared. When you differentiate this, you will have multiplied by 3y squared. The focus will now be on x. So we have 9 multiplied by, you have the x squared over dy, the x squared over the x, then we have y squared. Then this is equals to 9 multiplied by, when you differentiate this x squared, you have 2x, then you will now have y squared, multiplied by y squared. So by the time you multiply this, 9 times 2x times y squared, you have 18xy squared. So if you check very well, if you check this and this expression, they are equivalent, okay? So you have zxy equals zy. So this is what is called Young theorem. Young theorem. So according to Young theorem, the cross partial derivative of x on y is equivalent to the cross partial derivative of y on x. Thank you. See you in the next video. Before we go, let me give you a question to try. So let's say you have z equals to 10x to the power 4, yx to the power 3, and you are asked to find cross partial derivative. So how do you do that? What's your answer? Drop it in the comment section. Don't forget to follow this page and share the video so that many people will benefit from this video. Thank you. See you in the next video.